So for a discrete random variable, the mean or the expected value is given by this sum. And in our discussion or in this basic course, we are going to have x ranging only on a finite set of values. So that will be the sum of the values multiplied by the corresponding probabilities and add them up. And the variance is given by this rule, and standard deviation, as you know, is the square root of, or the positive square root of the variance. Okay, so now we are going to use Excel to obtain the mean and the standard deviation of the random variable, which takes on these values with these probabilities, and we are going to use Excel to accomplish it. So the first thing that I have done is that I have typed in all the values here. So x is ranging over these, and for px I have these values copied in the column. And just to make sure that this is a valid distribution, let's go ahead and add all these probabilities up, and this sum is 1, so this is a valid probability distribution. So now what we have to do first, we have to first multiply x with its corresponding probability. Okay, so of course we can multiply 4 by 0.04 and get 0.016, but here what we will do is we'll first put an equal sign, then click on this cell, and then click on the probability cell, and then here see, I did it wrong in my head. That's pretty embarrassing. Anyways, so 0.16, and in order to get all these values here, all I have to do is Control C, or I just went ahead and copied it, and I did Control V, and that gave me the values of the product of all these here. And then in this I can go ahead and obtain the sum of the column, sum of the cells above it in this column, and the mean turns out to be how much? 6.97. Remember this, that we just had, that the mean is given by the sum of the value of the variable multiplied with the corresponding probability. Now let's go ahead and find the expected value. So for the expected value, what we have to do, we have to subtract the mean from all the values, take the square and multiply it by the corresponding probability. And in the case of our spreadsheet, okay, what that will mean is that we have x minus, and here I'm just typing the value of the mean, which is 6.97, and the square is typed in like this in Excel, okay, and multiplied by the corresponding probability. So what I'll have to do is I'll again put an equal sign. Okay, this is the particular value that I'm looking at, and I'm subtracting 6.97 from this. I'm squaring it, all right, and then I'm multiplying it by what? The corresponding probability. So we got this here, and again we can go Control C or Control V, or I can just drag it down and get all these values down here. Do it in whichever way you please. All right, and then for the variance, all I have to do is that add all these values up. All right, let's do so. Here is our variance, right? Now, who is the standard deviation? The standard deviation is the square root of this quantity, right? Okay, so what we can do is we can say equal to, and the square root is given by SQRT, as it says that it will return the square root of a number. All right, I can click on this, or I can simply type it in. So whichever way you please. All right, and the standard deviation comes out to be how much? Approximately 1.87 to the 2 digits after the decimal sign. So now, even though we are done with our calculation, let's just, for curiosity's sake, look at a simulation here. So what I have done is that this is a package called Minitab, okay, a statistical software. So I copied the columns from Excel here, and in here we will just take some simulated values, okay, and so let's go to generation of random data. And of course you can do that in many other software, but so here we have discrete, right? So let's obtain 10,000 items in here, okay, and we are going to put that in the simulated values, and here is the X, here is PX, and it should generate a column of like 10,000 values for us. And let's see excuse me, what the mean and standard deviation of those values are. Well, they are not exactly what we have in there, but they are close. And whether they are like, if they are not close, later on we are going to, you know, develop a mechanism in which, like here, it's showing us that the mean is 6.93 instead of 6.97, and standard deviation is for this sample is how much? 1.86. Later on we are going to see that how to determine whether this departure from the actual mean is improbably far or not. But right now we just saw a result from this simulation, and of course if we resimulate we'll get a different result. And let's just do that. As I said, it's costing only your time, and I mean, I'm just fine with it. Let's see that this time what the mean and standard deviation are. So mean this time is like 6.98 and the standard deviation is 1.89. So excuse me.